the universe is a vast and mysterious place, filled with phenomena that continue to surprise and challenge us. For centuries, we have looked to the stars to understand our origins, the nature of space and time, and the fundamental forces that govern everything from the smallest particles to the largest galaxies. Over the years, our understanding of the cosmos has been shaped by scientific theories and discoveries that have stood the test of time. But recently, a groundbreaking shift has occurred in our understanding of the universe, all thanks to a new tool in the hands of scientists, the James Webb Space Telescope. This telescope, which is the most advanced and powerful space observatory ever created, has delivered a stream of astonishing revelations that are shaking the very foundations of modern science. From distant galaxies that defy our expectations to exoplanets exhibiting bizarre behaviors that break the known laws of physics, the findings from Webb are rewriting our understanding of the universe. In a sense, we are now experiencing a cosmic upheaval. Scientists are grappling with the realization that many of their long-held beliefs about space, time, and even the fundamental nature of reality itself may need to be revised. One of the most notable voices in the scientific community who has long predicted this kind of paradigm shift is Michio Kaku. Kaku, a world-renowned physicist and popular science communicator, has been outspoken about the limitations of our current scientific theories. For years, he has emphasized that our understanding of the universe is far from complete. In particular, Kaku has pointed out that we have never been able to reconcile the world of quantum mechanics, which governs the behavior of the smallest particles, with the theory of general relativity, which explains the behavior of massive objects like stars and galaxies. This gap in our understanding, Kaku argues, has led to a fragmented view of the universe. But now, thanks to the discoveries being made by the James Webb Space Telescope, scientists are beginning to realize just how incomplete our current theories really are. In his public statements, Kaku has predicted that the new data from Webb would force scientists to rethink everything they thought they knew about the cosmos. He has suggested that we would have to rewrite our textbooks and abandon outdated models that no longer hold up in light of new evidence. And indeed, as the images and data from Webb continue to flood in, it is becoming increasingly clear that the universe is far stranger and more complex than we ever imagined. The discoveries coming from this remarkable telescope are so groundbreaking that they challenge not only our understanding of space and time but also the very laws of physics that have governed our scientific models for centuries. The James Webb Space Telescope was launched into space with one clear mission: to fill in the gaps in our knowledge of the universe and confirm existing theories about the cosmos. However, as scientists are discovering, instead of confirming old ideas, Webb is appending them. The telescope has shown us a universe that is far more complex, chaotic, and awe-inspiring than we ever thought possible. Far from providing the answers we were expecting, Webb is raising more questions and forcing us to reconsider everything we thought we knew about the universe. The telescope itself is a technological marvel, a product of years of collaboration and innovation between NASA, the European Space Agency, and the Canadian Space Agency. With its powerful infrared capabilities, Webb is able to peer deep into space, far beyond the reach of other telescopes, and capture images that are both breathtakingly beautiful and scientifically significant. The data that Webb has already provided is allowing scientists to study distant galaxies, stars, and planetary systems with an unprecedented level of detail. And in many cases, the discoveries have been nothing short of astonishing. One of the most exciting aspects of the James Webb Space Telescope is its ability to study exoplanets, planets that orbit stars outside of our solar system. The search for exoplanets has been a major focus of astronomers for decades, and in recent years, advances in technology have made it possible to detect thousands of these distant worlds. But it is Webb's ability to analyze the light from these exoplanets in incredible detail that is allowing scientists to learn more about them than ever before. By using its advanced spectrometers, Webb can break down the light from a distant planet into its individual components, revealing information about its atmosphere, its chemical composition, and even the possibility of life. And yet, what Webb is showing us about these exoplanets is turning our understanding of planetary systems on its head. Take, for example, the discovery of KLT-9b, an exoplanet that is so strange that it defies the laws of physics as we know them. KLT-9b is an ultra-hot Neptune that orbits so close to its star that its surface temperature is high enough to break apart water molecules into their constituent parts, hydrogen and oxygen. This is a world so hot that even metals like iron are vaporized in its extreme conditions. But what makes KLT-9b even more extraordinary is the phenomenon of atmospheric blow-off, where the planet's atmosphere is literally blown away by the intense heat from its star. This discovery is not only unexpected but also unique among all known planetary atmospheres. And yet, it's just one of many examples of the kinds of exoplanets that Webb has uncovered, worlds that challenge our existing models of planetary formation and behavior. KLT-9b is far from the only exoplanet to break the rules. There's also WASP-76b, a giant planet that is so hot on one side that it has molten metals in its atmosphere. On the cooler, dark side of the planet, these metals solidify into iron and then fall back to the surface as rain. This bizarre phenomenon, metal rain on a planet millions of light-years away, is a stark reminder of how little we truly understand about the dynamics of exoplanets. And then there's WASP-17b, an exoplanet that orbits its star in the opposite direction from all the other planets in the same system. This retrograde orbit is considered scientifically impossible under the current models of planetary formation. Yet, WASP-17b exists, forcing astronomers to rethink everything they thought they knew about how planets form and move within their systems. These strange and unexpected discoveries are not limited to distant exoplanets. Even within our own solar system, the James Webb Space Telescope is uncovering mysteries that challenge our understanding of planetary science. Take, for example, the dwarf planet 2007 or 10, located in the Kuiper Belt. Webb's infrared scans of this distant object have revealed that it is unusually dark and red, with a surface rich in complex organic compounds. This discovery has raised more questions than answers. Why is 2007 or 10 so different from other dwarf planets in the Kuiper Belt? How did it form, and why is it so difficult to observe? These are questions that scientists are still grappling with, and they represent just one of the many mysteries that Webb is helping to unravel. Perhaps the most mind-boggling discovery to come from Webb, however, is the detection of rogue planets, planets that don't orbit stars at all. These vagabond planets are drifting through space, untethered to any particular star, and yet they exist in large numbers throughout the cosmos. The discovery of these rogue planets raises profound questions about their origins. How do they form, and how do they survive in the harsh, cold depths of space? One possibility is that these planets were ejected from their original star systems after gravitational interactions with other planets or nearby stars. Another possibility is that they formed independently, in star-forming regions, but without the mass necessary to ignite nuclear fusion and become stars themselves. The James Webb Space Telescope has also uncovered a surprising number of rogue Jupiter-like planets in the Orion Nebula. These planets, which have masses similar to Jupiter's, are not quite planets, but are somewhere between planets and brown dwarfs, which are the smallest stars known to exist. The fact that these objects are found in binary systems, pairs of planets orbiting each other in close proximity, was considered scientifically impossible until Webb's observations. The discovery of these rogue planets challenges our understanding of planetary formation and the forces that govern the behavior of objects in space. Are these objects actually planets, or are they something entirely new, an entirely different class of celestial bodies? This is just one more question that Webb is raising, and it is one that scientists are eager to explore. As the discoveries from the James Webb Space Telescope continue to pour in, it's becoming increasingly clear that the universe is far stranger and more complex than we ever imagined. The data coming from this incredible telescope is challenging our fundamental understanding of physics, cosmology, and planetary science. The more we learn, the more we realize that there is still so much we don't know. Our scientific models, which we once thought were solid and reliable, are now being questioned and even overturned in some cases. The universe is revealing itself to be a far more chaotic, unpredictable, and awe-inspiring place than we could have ever imagined. In the face of these revelations, some scientists are beginning to ask whether our current understanding of the universe is sufficient to explain the strange new worlds that Webb is uncovering. the discoveries from the telescope are forcing us to confront the possibility that our theories may be incomplete, and that we may need to rethink everything we thought we knew about the cosmos. The revolution in astrophysics that is currently underway is a testament to the power of scientific exploration and the importance of pushing the boundaries of our knowledge. With each new discovery, we are forced to confront the reality that the universe is far more mysterious and complex than we could have ever imagined. So what comes next? How do scientists move forward in the face of these incredible new discoveries? The truth is, no one knows for sure. But one thing is certain: the James Webb Space Telescope has opened up a new era of space exploration, one that promises to reshape our understanding of the universe and our place within it. As we continue to explore the cosmos, we are bound to encounter even more strange and unexpected phenomena that may forever change the way we think about the universe. The quest for knowledge is far from over, and with the help of the James Webb Space Telescope, we are closer than ever to unlocking the deepest mysteries of the cosmos.